Ladies and gentlemen, please welcome Vice President, AEC, Nicolas Mangon.
Good morning and welcome. Bonjour et bienvenue. We didn't actually expect that many people today after the party last night, so congratulations on making it to the final day of Autodesk University 2017. This is my 15th AU, and for me, the most exciting one. Why? Because I can see the future is right here at AU. Think about it. The way we live, play, and work is changing. Billions of connected objects are generating a flood of data. And so many things are automated. For example, everything can be geolocated. You may be receiving your packages from GPS-guided drones in the near future. With infinite computing powers, smart devices process big data, such as traffic analysis or construction work, to help you find your fastest route home. Sensors help us to lose weight, some of us, and push us to run faster. Or, in my case, I can monitor what my 4 girls are up to when I travel. Yeah, I know it's sad, they don't like it. Well. Now, apply that same kind of automation to the work you do. Planning, designing, engineering, fabricating, constructing, managing buildings and infrastructures. Just like the way you shop or find your way home has changed, the way you work will change too. But as Andrew pointed out, automation is not the silver bullet that suddenly is going to make our industry more productive. Why is that? When you look at the process to deliver a complete project, it's no surprise. Come on, look at that, right? Our friends at the Beck Group took time to illustrate just how fragmented and complex it is. So how can we possibly create more and do it better when we are managing so much complexity? And app for that is not going to help. Software that fixes one piece of the process at a time is not the solution. The benefit of automation relies on connecting the data and the people and the processes. Data has always been central to the promise of BIM. We hear you when you say that you want to work in more connected ways across teams and time zones. When you add the power of the cloud to BIM, that changes everything. Connected BIM is BIM plus the power of the cloud. Let me say it again, it's important. Connected BIM is BIM plus the power of the cloud. And as Amy Bunzel said yesterday, we are working with you to put data at the center and help you connect the digital and physical aspects of your projects. I want to share with you 2 brief examples of how your colleagues are using BIM in more connected ways. The Grand Paris Express project, or Grand Paris Express Projet, is one of the largest infrastructure projects in the world. It will create 200 kilometers of new railway network with 68 new train stations, and 90% of it will be underground. It's one of the first infrastructure projects of this scale to use BIM from start to finish. 37 architectural and civil engineering design firms are participating in the project. And they are all producing horizontal and vertical infrastructure BIM models together using Civil 3D and Revit. They optimize their design by simulating things like smoke extraction, escape route, and optimal equipment locations. Better collaboration across all stakeholders is keeping the project on time and on budget. Or take this amazing building in Dubai. The Museum of the Future is integrating digital design and construction to push the boundaries of what's possible. They actually won the first prize of the AEC Excellence Awards this week. It's an amazing project. They are using a fully developed digital workflows across the project lifecycle to support the LEED Platinum objective. And they are using cloud-based tool technologies for energy, solar, daylight, and ventilation analysis. In addition, with design for construction built in the Revit-based handover process, plus the use of BIM 360 field in the field, a 65 reduction in rework is projected, 65%. So what's next? How does data enable us to work smarter? Remember, data feeds automation in ways such as machine learning and artificial intelligence. Automation augments our human capabilities. It is changing the way we work, and there is so much we can do. It's worth repeating. We can do more and achieve better results with less negative impact. Take generative design as an example. You describe the optimal outcome, and the computer explores thousands of potential solutions for you. On Tuesday, Hilbrand Katzma from Van Wijnen talked about this. Their land development example looked at an urban neighborhood and set performance criteria like backyard size, sunlight access, and views. They also set business criteria for the land developer, like cost of development, quality, and time to market. Then the software went to work, testing and learning from each iteration what works and what doesn't, in order to come up with several options that provide the optimal solution. In this real-world project example, Van Wijnen leveraged generative design to help them build more housing, at the same time meeting their own business objectives. At Autodesk, we tested the application of generative design to help us better optimize space in our Toronto office renovation. We surveyed our employees about their preference for collaboration space, lighting, acoustics, and distance to the kitchen, and sometimes distance to the bathroom. Then we fed that criteria into the artificial intelligence software. You can see the process running as different floor plan layouts are being created. With this type of automation, infinite compute power augments our ability to design a better space to the delight of our employees. We can also apply generative design to civil engineering. Grading on infrastructure projects can be complicated and require many time-consuming tries to achieve the best results. By analyzing the shape of existing ground and applying geometric constraints, hundreds or even thousands of solutions can be tested without even breaking ground. This is an example of how generative design can support low-impact development, so we have a less negative impact on the environment. I wish I had that when I was practicing civil engineering. All of these examples take place before construction starts. So how can machine learning help us on the construction site? Ask any contractor what their #1 concern is, and it is always safety. Connecting machine learning, the Internet of Things, and BIM-based analytics are helping contractors to address safety concerns. Construction sites are generating more photo and video data than ever before. Smartphones, tablets, side cameras, and even drones continue to the explosion of visual content. SmartVid is using machine learning to turn this visual content into an opportunity to improve safety. In less than 90 seconds, you can connect your project data from BIM 360 Field and BIM 360 Docs and start mining it for safety insight, like, for instance, flagging missing personal safety equipment. You can use the results to reinforce safety protocols during your daily project meetings on site. We see SmartVid as the future of construction, and we recently invested in them so that they can accelerate this kind of innovation. Here's another example. The Internet of Things is helping contractors to build more safely than ever before. Autodesk is partnering with the Triax Technologies to address safety challenges on site with wearable sensors that collect and transmit workforce and safety information in real time. If a worker slips, trips, or falls on the job site, sensors detect the incident and send an automatic alert to site personnel. The notification tells you who, when, where, and how the incident occurred, resulting in faster and better response to injuries. And what if a site needs to be suddenly evacuated? In their product Spotter, an evacuation alarm is triggered, and supervisors can track evacuation progress in real time. Now, consider the potential of this workflow in the context of a Revit model that's hosted in the cloud. BIM visualization could help supervisors in locating precisely workers who've had an accident. We've said it, the value of the data is in the connection. What if we could take data coming from multiple sources like sensors, cameras, IoT devices, or any place across the project and visualize them against the palette of a building information model? Think about it. We would be able to derive even more powerful insight to improve quality, safety, and efficiency. Think about Navisworks for IoT data visualization in real time. Pillar Technologies is also working on ways to detect problems on the site. For instance, identifying humidity issues, which could over time lead to mold growth, or helping to limit worker exposure to harmful materials, including high concentration of airborne particulates. In this visualization of the data, you can better understand safe versus unsafe zones at different times of the day and run historical reports to understand these changing conditions. Now, add the data from Triax, and you can see workers who've had a fall event or responded to unsafe conditions, resulting in worker evacuation. And take a look at this from versatile natures. We can visualize sensors from cranes to better understand loads and safe zones for workers. It's incredible what is possible when combining BIM with the power of the cloud and connected devices. Don't you think? Don't you think? Thank you. In this case, it's a single environment to visualize IoT data from the construction site in real time. Your potential is limitless. The amount of data that you will be able to create, capture, and compute will continue to grow. Our goal is to make that data more useful to you, provide better insight, and make it more valuable in running your projects. So how are we doing that? Our development efforts are focused on delivering more connected ways of working. We are building platforms, APIs, and workflows that help you connect to the data and the people and the processes, no matter who you are, what you do, or what you are on the project. Autodesk continues to build a common data platform across A, E, and C, beginning with construction and extending upstream to design collaboration and downstream into operations and maintenance. That platform is BIM 360. And it is the way in which we are connecting you to the compute power, data, and insight that you need to create more and better, waste less, and build a better world. Now, here to tell you more about BIM 360, please welcome my friend and colleague, Sarah Hodges.
Wow. Good morning. This is quite the room full. Welcome. Thank you, Nicolas. To me, it's clear that the possibilities in front of us are indeed exciting. But I have to tell you, I spend numerous days out on project sites, not in my high heels, I promise you. And to me, it's clear that you have challenges that you're facing today. Many of you are digitizing your projects and your company. You're looking to break down the barriers around collaboration, all while continuing to strive for a higher profit margin. And you do all of this while making the seemingly impossible possible. Take this project as an example, the China Zun Tower. It's the world's first ultra high-rise building, and it stands at over 500 meters in height. It has the largest in the world concrete-filled multi-steel cavity that took 256 trucks pouring 96 hours nonstop in order to fill. And the structural system, it's so complex, it had to be produced and assembled off-site. The China Construction 3rd Engineering Bureau Group are constructing this building using BIM 360. With BIM 360, it's helping them to coordinate smarter and collaborate better. But don't take my word for it. I'd like to prove it. The China Construction 3rd Engineering Bureau Group are receiving 80% fewer change orders using BIM 360 on this project. And they've identified literally thousands of issues prior to construction. BIM 360 is bringing predictability to the chaos of the construction process. And yet, despite growing demand, despite technology innovation, and despite the fact that projects continue to grow in complexity, project workflows are fragmented, data lives in silos, and teams, for the most part, are disconnected. Digitization, a seemingly simple concept, could bring staggering results to the construction industry. That 13 to 21% correlates to a $1.2 trillion savings on a $10 trillion output. The argument for technology in construction is clear. No project should ever start without a technology strategy. But the level of technology investment in construction today remains extremely low. I'm here to share with you that we're going to change that. I stood on this very stage last year, and I told you about all the developments we were pouring into BIM 360. BIM 360 is our solution to the app for that phenomenon out in the construction technology industry. It's a place for sharing your 2D information, your 3D information is your single source of truth. Over the years, our approach has been validated by many of you who are here with us today. For example, JG Rattigan. They're a large main contractor in Ireland, and they've been using the full BIM 360 portfolio on all of their proper projects. They've used BIM 360 Glue to coordinate with design teams during pre-construction. They've used BIM 360 Field out in the field for managing safety and quality, and BIM 360 Docs for uniting all project information across pre-construction, site execution, and even for handover. The progress that they have had with BIM 360 is indeed impressive. But they, like many of you, continue to ask us the same question. Why do I have to put my information in 3 BIM 360 products? It doesn't solve the fragmentation and doesn't help with having disparate project information in multiple locations. Well, we've been listening. Over the past year, we have launched over 100 features in the BIM 360 family, and we focused on digitizing the project, as well as focusing on construction workflows that are important to you. Many of you here today were part of the 150 construction customers we worked with over the past year, and you gave us 5,000 pieces of input. I'm delighted to tell you that we took that input and we folded it into what we are announcing today as our next generation BIM 360 platform. It's one application, one single source of truth, one common data platform. We believe so strongly that the next generation platform is a direct result of the input that you've shared with us that we invite you to try it for yourself. Announced earlier this week, BIM 360 is now available as a public technology preview, and we encourage you to test, to implement, and to pilot this on your next project. The next generation platform removes the need to have disparate projects, disparate information, and different solutions throughout your project. It starts with the digitization of your information, housing it all in the central repository, or the common data platform. Familiar and necessary tasks of design coordination, clash detection are integrated into the platform. And they're not just integrated, they're also automated. This means project stakeholders can benefit from the results and the insight, and it can inform across the entire project, leading to greater accuracy, more transparency, as well as deeper accountability. Now, we recognize on any given project, you have a plethora of data and other solutions that you need to use across your project. That's why I'm delighted to also announce the arrival of Autodesk's Connect and Construct Exchange. It's your one-stop shop for third-party integrations into the next generation BIM 360 platform. Using Connect and Construct Exchange, all of your project information can be integrated into the platform with just a few simple clicks in the App Store. For example, sync your files from wherever they may reside or wherever you may have shared them. Through the Connect and Construct Exchange, we are prioritizing third-party integrations that are important to you. We recognize the value of data created during the pre-construction phase, both pre-contract and post-contract. That's why I'm delighted to announce our strategic investment and partnership with Assemble Systems. Through this partnership, we'll be able to take information created during the design phase and pre-construction phase, disassemble it, carry it out to the construction site. But also, equally importantly, that information can inform the design process. We are truly creating a connection between design and construction. This is the next generation BIM 360 platform. It connects all data, all project teams, and the entire ecosystem. It's unleashing the power of data. So we recognize that digitization and automation, they are the backbone to any technology strategy in construction. But we know it doesn't end there. The way buildings, the way roads, the way bridges are being constructed, it's changing. It's going through an evolution. BIM 360, it's going to evolve with the industry. In fact, it's already an evolution. We've taken best-of-breed technology from the office with best-of-breed technology from the field, and we've united that together. And because the next generation BIM 360 platform is predicated on Forge, our cloud development solution, it's open and it's extensible. We'll be accelerating the extensibility through the Connect and Construct Exchange, but also, because of Forge, it enables you to develop any custom needs that you may also have. But let's look again at where we are today. We're connecting the process of construction projects, from project management to site execution, all in one unified application. This allows project teams to have access to the information that they need when they need it. It allows them to minimize risk and rework, maximize accuracy, and it allows teams to spend more time focusing on critical tasks that are important to the project progression. We recognize that on any given project, you have a plethora of stakeholders providing you critical information to your project. So we've embedded submittal-based workflows into the next generation platform. It allows all project data to be centralized and accessible. Subcontractors, trades, they receive submittal information. They can respond to it in the same system. Everything is tracked. Everything is audible. And workflow rules, they allow you to have control over what information you share and to who, and ensure just-in-time information gets out to the construction site. Now, what about out on the site? Well, rework is minimized with checklist, punch list, issue management, all in an elegant and, dare I say, enjoyable experience. And whether you use Apple or Android, that experience is exactly the same. Every change, every issue, every comment is put in context of the overall project. And paramount to transparency that you all require, anytime there is a change, it's logged and available so you can completely avoid finger pointing and inappropriate blame. But we're not stopping there. We're never done. We recognize the importance of the pre-construction workflow as well as what's happening out on the construction site. And in the next few months, we'll be working with a select few number of customers in our Insider program to have you help us validate and provide input to a cost management module that will manifest itself within the BIM 360 environment. We recognize the value of being able to forecast the impact to cost, the moment a change happens, because we all know those changes ripple throughout our project. We need to handle the cost changes in a unified way. That's what BIM 360 will provide. This is not how construction projects will be delivered in the future. It's how they can be delivered today with BIM 360. And when you have all of that data accessible to you in the project, it provides great clarity into what you're doing. But imagine, what if you can have clarity not just over your existing project, but over a pipeline of future projects? Well, the BIM 360 platform, it's built with a backbone towards analytics and insight. It's already established and set up for things like machine learning, artificial intelligence. And I'm not making this up. In fact, our machine learning engine, Project IQ, is already busy at work. Over the past several months, in combination with many of you here today, Project IQ has analyzed 225 individual pieces of data, including 30 million issues. That's 30 million times something went wrong on a construction site. So what are we doing with that data? It's being used to develop algorithms that can help us predict outcomes on future projects so we can avoid issues entirely. With Project IQ, our customers are changing the way that they build. They're using data-driven insight to better predict outcomes, and they're redirecting work as well as prioritizing work for their teams. They're guiding teams to avoid incidents before they even happen. BIM 360 with Project IQ is moving projects from uncertainty into project predictability. But we're taking Project IQ even one step further. And we're helping safety managers, quality managers, project leaders to have leading indicators accessible to them. These leading indicators can help them identify potential safety issues on a project before they even happen. That's the path to less risk. That's the path to better predictability and better outcomes. And it starts today by getting your projects in BIM 360. So as the BIM 360 platform connects teams, connects data, connects the ecosystem, we recognize that we're solving some very challenging integration issues across the project. But we also recognize that no building is ever built without a need for very, very strong collaboration and communication across all project teams. That's why we're also thinking about the fragmentation that happens in the design process. Just as the construction site is a fragmented process, there's a lot of fragmentation that happens up during in design. Many of you here today are solving that fragmentation using Collaboration for Revit. With Collaboration for Revit, you're editing, you're coordinating, you're collaborating on shared Revit models in the cloud. For example, take WeWork. They are an innovative, fast-growing company. They've standardized their entire teams on Collaboration for Revit. Their teams are geographically dispersed, but they're able to work together to review, to edit, to coordinate, and to collaborate in the cloud using Collaboration for Revit. WeWork is able to deliver the co-working spaces around the world that they're known for based on this cloud-connected portfolio. Another customer having great success with our cloud-connected tools is Macmillan Pasden Smith. Unfortunately, they were recently hit hard by Hurricane Irma. It left many of their offices with intermittent access to power, and in some cases, no power at all. Fortunately, they'd moved a number of their projects into the cloud recently, and they were able to still meet their milestones, please their clients, and complete their projects using Collaboration for Revit. Since then, they've moved 100% of their projects into the cloud. Now, these are not unique examples. What you see here is an actual map of real usage. 144 countries are using Collaboration for Revit. That's resulted in 100,000 models being in the cloud, of which in any given month, 1.6 million updates are occurring. 1.6 million. We conservatively estimate that that has saved our customers 1 million hours in 1 month alone. That time otherwise would have been spent changing design changes and communicating back through the teams. Talk about efficiency. But it's not just about connecting teams who are using Revit. What if that data could also be accessed within the common data platform? I want to share with you what we're doing to create a better work experience across all disciplines, architects, engineers, and contractors. I'm pleased to share with you our next generation of Collaboration for Revit. It's going to manifest itself as part of BIM 360 as design collaboration features. And it's going to make BIM dramatically more accessible. What you see here, it's an aggregated view of all project data. And it's organized in the way that teams actually think about their project. No upload, no export is ever even required. In BIM 360, we'll introduce the idea of multidisciplinary teams being able to coordinate together in a way never before possible. No more traversing for a complicated PDF file system, or no more leaning over the shoulder of a designer to see the status of the project. Instead, simply isolate a view, and in real time, you can see where you are in the project and the status of it. Mechanical, electrical, plumbing, architectural models, they're all aggregated and visible in a centralized model hosted in the cloud. Now we recognize the state of that model is constantly changing. Design is an iterative process. So we're working to visualize the exchange of that information between teams, and we're doing it across the timeline of a project. It's delivering clarity to the chaos of teams constantly uploading and downloading files to shared cloud folders. That exchange of information, it happens in a managed way. So if I'm the project manager, I know exactly where I am in the project, I know what my deliverables are, and I know what milestones I need to meet next. I no longer have to track anything in disparate spreadsheets. We'll also introduce the idea of package transmittals, each curated by the design team that actually authored them. This way, individual teams can control what information they share, who they share it to, and it can all be consumed back into the centralized system for consumption by the rest of the team. The best part? It's one connected workspace, one common data platform. It supports the way design teams need to work, and it supports the way construction teams need to participate in the process, regardless of what contract structure they have. Now, as collaboration extends to all project contributors, we recognize we have to have this kind of cloud-connected technology outside of just Revit. That's why I'm pleased to announce we're making the same type of authoring and cloud collaboration connectivity across other key AEC authoring solutions: Civil 3D, InfoWorks, Plant 3D. Soon, civil infrastructure teams can benefit from the same type of cloud-connected workflows. Imagine your Civil 3D project in the cloud. Here it is. With BIM 360, we're working to enable multi-discipline BIM. We're looking not just at horizontal and vertical, but we're looking at it together. Horizontal and vertical infrastructure enabled by the BIM 360 platform. Because let's be honest, every project has a site. What you're seeing here is civil infrastructure teams being able to collaborate and participate in the same design process working in the cloud. They can work in the cloud with their individual teams, as well as work across multidisciplinary teams across architecture, engineering, and construction. BIM 360 is a platform that's connecting design and build, and it's connecting teams in a way like never before possible. But we're still not done. In the coming months, BIM 360 is going to put change visualization and clash detection tools into the hands of design teams. Teams are constantly iterating as the teams are constantly iterating because we know the design is constantly going through various stages. So we're investing in making sure that that is actually happening visually for you and your teams. You're able to visually represent changes. Instead of having to track down revisions, your team can actually take action on them. And BIM 360 is going to allow design teams to spot potential issues and clashes. Design teams. They can actually spot them before they even hand over the project to construction. And most importantly, all of these changes, all of these results are being aggregated into one centralized workspace within the common data platform. This accessible experience of aggregated models and packages, it's available to both design and construction teams. It supports design, pre-construction, and site execution. If an issue arises, an RFI can be created, and it can be solved for, changes captured, all within the system of record. So what did we see here? We saw a few things. A more seamless connection from your authoring applications with data in the cloud. We also saw multidisciplinary teams working together in a shared but controlled workspace. And we saw construction teams taking action based on having up-to-date information accessible to them in the common data platform. With the project at the center, we are working towards one shared goal: successful project delivery. It's like Nicolas said, our aim is to connect teams to the data and increase as well as enrich the value of that data across the project. No one else is connecting your authoring applications to a common data platform. No one else is aggregating the data across your project and connecting it into the platform. No one else is democratizing the value of BIM, as well as adding project controls. Before I go, I want to remind you of three key things. Number one, BIM 360 is a unified common data platform that's not only digitizing what happens out on the construction site, but optimizing the pre-construction workflows. Number two, we are bringing design, authoring, and work sharing tools into the BIM 360 platform. And number three, we are building an open platform that supports all types of data, and we're accelerating the accessibility of that through Connect and Construct Exchange. If you have not yet started a project in BIM 360, what are you waiting for? Remember, it's the foundation for realizing the potential of data on your projects, both today and tomorrow. So to give you a glimpse into what tomorrow may look like, I'd like to invite Jim Lynch to the stage.
I'm good, thank you. All right, thank you, Sarah. Good morning. So at the beginning of this session, Nicolas talked about what is possible with data and automation. And Sarah, of course, just laid out how, with BIM 360, we're building a foundation to help you realize that potential. So let me start out by describing where we're headed with BIM 360, specifically as it relates to collaboration. Now, I'll start by talking about a topic we raised last year here at AU, Project Quantum. Quantum is an initiative for connecting applications and services via a common data platform for efficient project delivery across all AEC disciplines. The goal of Quantum is to streamline data flow from design to fabrication all the way through to the construction site. Now, in order to fully understand what that means, let's put it in the context of where we are today. As Sarah shared with you, today there are many ways to collaborate with your teams. In BIM 360, we first introduced file-based collaboration offered by document and data management services for storage, for sharing, and for reviewing. Now soon, we're introducing technology for cloud work sharing, where teams have access to shared central models using BIM 360 to coordinate milestones and deliverables across BIM project teams. Tomorrow, the technology born as Project Quantum will be integrated into BIM 360 and will enable an entirely new level of collaboration and data exchange between design, fabrication, and construction across any platform. This will enable tighter collaboration and control over project workflows, and it's essential to support what comes next. So let me set some context. In the next 20 years or so, there will be 2 billion more people on the planet. Now just think of the demand for buildings and infrastructure that will be required to support this population, most of whom will live in cities. With the lack of predictability and historical low productivity, we must ask ourselves, are the same old methods the best approach to meet the demand? Now, using an example from my hometown of Boston, of course you can't tell with my French accent, the Big Dig, a mega infrastructure project, was meant to take 6 years to complete. Instead, it took over 20 years to complete, with the cost overrun of 190%. Now, I know that's an extreme example, but we all know projects that completely miss their schedule and/or their budget. The point is, we cannot meet the demand if we don't consider new ways of designing, fabricating, or constructing. Progressive thinking, innovation, and determination are critical to addressing the industry challenges we all encounter. Specifically, we must look to the manufacturing industry in sectors such as automotive and consumer products, which must really produce large amounts of high-quality products consistently and efficiently. We believe the AEC has to learn lessons from the manufacturing world in order to boost productivity. The industrialization of construction is the convergence of manufacturing and construction processes. In the next few years, this convergence will radically change the way we design buildings, make their components, assemble them on site, and manage the processes and data. In the future, buildings will be assembled from components and modules that were manufactured off-site. This transformation will require all project stakeholders, designers, engineers, fabricators, and contractors to adopt new methodologies. This means designers will have a greater impact on how buildings are made and constructed. This idea is known as Design for Manufacture and Assembly, or DFMA. DFMA focuses on manufacturing throughput and efficiency of assembly and is a well-established approach in markets such as automotive. For sure, AEC is an extreme case of mass customization. However, if we really look at it, the majority of the buildings we make have repetitive content. I mean, just think of any residential building, hospital, hotel, school, or data center. And today, we simply don't have a smart way of dealing with them, neither in the design process nor in the construction process. To meet the demand without sacrificing quality or increasing our environmental footprint, we must find a way to help building design process consider more modular and standardized approaches. Our tools will support design for manufacture and assembly by first codifying intelligence and logic to help design buildings that are optimized for off-site construction, and by embedding fabrication knowledge to enable factories to streamline their processes. So imagine, for example, if you had a DFMA assistant for facade panelization that could bridge design, estimation, procurement, and fabrication. an assistant that helps fabricators create smart libraries that will contain all manufacturing knowledge and constraints, streamline the estimation and engineering of the facade, and empower designers to connect design and fabrication. Or a DFMA assistant for modular construction. This hospital that you see here was designed by the Nordic Office of Architecture, and it includes a high level of repetition in terms of the floors, the rooms, and the components. And by the way, I really want to thank Nordic Office of Architecture for sharing this project with us. But imagine if a smart assistant could help the architect focus the design on the way buildings are built and delivered. A sort of analytical tool that, based on input and previous experiences, helps designers create a library of standard but configurable modules. The process would start with conceptual parametric placeholders that are simple in geometry but extremely, extremely rich in data. This would initially help play out different design scenarios, but it would also enable early estimation and procurement. In later stages, the modules and components can be further developed, getting more precise and detailed in terms of geometry and also supply chain data. Now, of course, this approach doesn't mean that all modules must be the same. On the contrary, modules can be mirrored, configured, and adjusted. DFMA will allow for mass customization while at the same time streamlining processes from design to manufacturing and assembly. Individual modules can be designed for flat pack delivery, similar to how one of our newest partners, Project Frog, is working, or volumetric modules, as we see here, again, from Nordic Office of Architecture. The individual modules can be combined further into bigger cross-discipline assemblies that hold fabrication intelligence and assembly instructions. But what will the AEC factory of the future look like? The make part of the process is also changing, and the off-site construction factories of the future will be producing multi-material, multi-discipline panels and modules all in the same place. The machining process will become automated, following recipes and fabrication logic delivered directly from the DFMA-empowered BIM data. And assembly instructions will be generated from these smart models. The sequencing for producing components will be managed to optimize factory efficiency while also meeting the project needs. Compared with working on-site, off-site construction is safer and more efficient. It's also easier to manage quality and to ensure precision. Components created in these factories will have individual identifiers, such as QR codes, that allow for tracking and monitoring from design to production, through delivery, through installation. This would be done via a collaborative cloud solution, similar to how one of our partners, Manufacton, does it. Manufacton provides a SaaS platform for construction firms to plan, track, and manage prefab elements across all supply chain members, including detailers, procurement, shop foremen, and field superintendents. So finally, we move to the construction site. Construction sites of the future will become increasingly automated. Imagine an assembly line on the construction site instead of in the factory. Assembling, rather than constructing building parts on the project site, will drive greater efficiency. And there'll be less waste and therefore less impact on the environment. Installation instructions coming from the BIM model will enable flawless assembly of building parts on the job site. And as I mentioned earlier, QR codes embedded in the modules at the factory will allow for live tracking from production, delivery, and ultimately installation. And of course, this will enable just-in-time delivery and just-in-time production. For the first time, data flows from the design to the project site seamlessly. Now, we're also seeing inspiring innovation in robotics on the construction site. Recently, I had the opportunity to visit a DFAB house at ETH Zurich, where robots were building up rebar and laying complex brick walls. This is part of the Swiss National Center of Competence in Research. We're also seeing large-scale building structures, or even entire buildings, being 3D printed using various materials such as concrete, clay, and even polymers. Just like you see here from the team at X-Tree. Or how about self-driving heavy equipment that makes construction safer, faster, and more affordable, such as built robotics? And we're conducting research on concepts for VR-controlled construction robots that have the machine learning capabilities that learn how to do installations over time. The convergence of manufacturing and AEC is the future of construction. Progressive thinking, innovation, and determination are critical to meeting the demands and embracing the opportunities in front of all of us. This transformational approach to the way buildings are designed, procured, and delivered will radically change our lives and will enable us to meet the demands of the future. Think of how robotics and automation have changed automotive production and the resulting improvements in the cars we drive today. Think about the automotive manufacturers that embrace new technology and are reaping success. And think about those that haven't. Are you ready to embrace DFMA? Are you ready to consider factory automation and on-site assembly over traditional construction methods? Now, before I leave, I'd like to recap what you heard this morning. To paraphrase both Nicolas and Sarah, our job is to provide you the tools you need to connect people, processes, and data. That's possible today with BIM 360. Today, you also heard us announce a unified BIM 360 platform and how we're extending BIM 360 to include design collaboration workflows across AEC. You also heard we're making new investments to connect workflows and increase the value of data. We're giving you more access to the software integrations you've been asking for. And finally, the convergence of manufacturing and AEC is real, and it's happening now. Autodesk was your partner at the very beginning of the BIM transformation, and we're committed to partner with you in the future of design, fabrication, construction, and collaboration. Your potential is limitless. I'm deeply excited about what we can do today and in the future, and I hope you are too. Let's go build the future together. Thank you.